Point xy lies on the circumference of a circle with radius 3 and center at the origin. Find the maximal value of x square plus 3y squared plus 4x. The equation to a circle with center at the origin and a radius 3 is x square plus y square is equal to 9. Since the arbitrary point xy lies on this circle, its coordinates must satisfy the equation of the circle. So from this equation we get y square is equal to 9 minus x square. Therefore 3y square is equal to 27 minus 3x square. Now we are supposed to find out the maximal value of the expression x square plus 3y square plus 4x square. In this we replace 3y square with the value we found just now, that is 27 minus 3x square, to get x square plus 27 minus 3x square plus 4x, and that becomes minus 2x square plus 4x plus 27. Let's call it equation 1. Or x square plus 3y square plus 4x is equal to, if you take minus 2 common on the right hand side, we get minus 2 multiplied by within bracket x squared minus 2x plus 27, and that is equal to minus 2 within bracket x squared minus 2x plus 1 minus 1 plus 27. We have added plus 1 and subtracted minus 1 in the bracket so that we get a squared term. So the left hand side is equal to minus 2 whole multiplied by x minus 1 whole square minus 1 bracket ends plus 27, and that is equal to minus 2 multiplied by x minus 1 whole square plus 2 plus 27, and this is equal to minus 2 multiplied by x minus 1 whole square plus 29. The maximum value of the given expression x square plus 3y square plus 4x is therefore the same as the maximum value of 29 minus 2 multiplied by x minus 1 whole squared. Since x minus 1 whole squared can never be negative, it is obvious that 29 minus 2 multiplied by x minus 1 whole square will attain its highest value when the term 2 multiplied by x minus 1 whole square has the lowest value. Since x minus 1 is always 0 or positive, its lowest value is 0, and this happens when x is equal to 1. Thus, highest value of x square plus 3y square plus 4x is equal to the highest value of 29 minus 2 multiplied by x minus 1 whole squared, that is equal to 29 minus 0, and that is 29. More formally, we can use the following method if you know calculus. We have already derived that the given expression, that is x square plus 3y square plus 4x, is equal to minus 2x square plus 4x plus 27 as seen from equation 1. Though not essential to solve the problem, the graph of this expression 2x square plus 4x plus 27 is plotted at the end of this video to show how it varies as x changes. Let us say g is equal to minus 2x square plus 4x plus 27. Then G will be an extremum, that is a maximum or a minimum for those values of x for which the derivative of g with respect to x, that is dz by dx, dg by dx is equal to 0. Moreover, at these values of x, if the second derivative is negative, then it is a maximum. If the second derivative is positive, then it is a minimum. And if the second derivative is 0, then it is a point of inflection. In this case, g is equal to minus 2x square plus 4x plus 27. Therefore, the first derivative dg by dx is equal to minus 4x plus 4, or if you take minus 4 common, then the first derivative is minus 4 multiplied by x minus 1. Let us call it equation 2. And the second derivative d square g divided by dx square is equal to minus 4. Let us call it equation 3. The plot of dg by dx is equal to minus 4x plus 4 is also given below at the end of the video. Note from the plot that the slope of the graph is minus 4. Since slope of dg by dx plot is given by d square g by dx square, we have d square g by ds square is equal to minus 4 graphically also. From equation 2, dg by dx is equal to 0 when x is equal to 1. Remember, equation 2 was dg by dx was minus 4 multiplied by x minus 1. So, this is 0 when x is equal to 1. Also, from equation 3, d square g by dx square, which was minus 4 and that was negative. Note that d square g by dx square is negative irrespective of the value of x, that is for all values of x. Hence, d square g by dx square is negative at x is equal to 1 also. Therefore, the function g is equal to minus 2x square plus 4x plus 27 has a maximum at x is equal to 1. And the maximum value is obtained by putting x is equal to 1 in the given expression, and that is 2 multiplied by 1 squared plus 4 multiplied by 1 plus 27, and that is equal to 29. Thus, the maximum value of x square plus 3y square plus 4x is equal to 29. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Here, we have given a graphical representation of the problem. On the left hand side, we have plotted the expression minus 2x square plus 4x plus 27, which we are calling g, and that is plotted against x. We see that the curve increases from negative values of x, reaches a maximum, then again comes down. At the point x is equal to 1, it reaches a maximum value. We are calling it G max, and the maximum value from the graph is 29. And this is the result we are supposed to get in this problem. On the right hand side, we have given another graph where we have plotted the first derivative of g with respect to x, that is dg by dx is plotted versus x. Observe that dg by dx becomes 0 at x is equal to 1. Also note that the slope of the graph is negative because dg by dx decreases when x increases. Now the slope of the graph is d square g by dx square, or the second derivative. Therefore, we conclude that the second derivative is negative, and that is -4. Thank you.